Have you ever looked up at a bright point of light, a really bright one, and wondered if it was actually more? What if you could see, say, Jupiter, not just as a brilliant dot, but actually watch its moons circling it? Or see its cloud bands, maybe even that famous Great Red Spot. Or imagine looking at Saturn and seeing those rings, really seeing them. If that kind of gets you excited, well, this deep dive is definitely for you. We're going to give you the shortcut to making that happen.
Yeah, we're diving into planetary oppositions happening in 2025. And it's not just about circling dates on a calendar. We want you to understand why these events are so special, astronomically speaking.
Right, and how you can actually see these things, whether you've just got your own eyes or maybe some binoculars or even a small telescope.
Exactly, because opposition, well, it really is the absolute best time to look at planets. You get maximum brightness, they're closest to Earth, and they're visible all night long. It just sets the stage perfectly.
Okay, so let's break that down. Opposition. What exactly is that? I sometimes think of it like a racetrack, the solar system, right?
Mm-hmm. That's a great analogy.
Earth's on the inside lane going faster. And Jupiter or Saturn, one of the outer guys, is on an outer lane going slower. Opposition is like that moment Earth laps the outer planet, passes right between it and the sun, like we're shouting on your left as we zoom by.
Yeah, that's a perfect way to visualize it. And astronomically, the definition is pretty precise. It's when the sun, the Earth, and that other body, a planet, maybe an asteroid, line up perfectly straight with Earth smack in the middle.
Okay, so the planet is 180 degrees away from the sun in our sky.
Exactly. Which means, think about it, as the sun is setting over in the west,
The planet is rising in the east.
Precisely. Ready for a whole night of viewing. It's just like a full moon, actually. A full moon is technically the moon in opposition.
Oh, interesting. Okay, so why is this such a big deal for us, the observers on Earth?
Yeah.
What are the actual benefits?
Well, first off, closest approach. That alignment means the planet is literally as close to Earth as it's going to get for that entire year.
So it looks bigger.
Yeah. Through binoculars or a telescope, it appears largest. Mars is the classic example. The size difference between opposition and when it's far away is really dramatic. You can go from seeing just a red dot to a clear disk.
Wow. Okay, closest approach. Got it. What else?
Well, that closeness links to the next point, maximum brightness. Because Earth is between the sun and the planet, the side of the planet we see is fully lit up by the sun, just like that full moon again.
Fully illuminated, so it shines its brightest.
That is absolute brightest for the year, yeah. Easier to spot with the naked eye, and you see more detail through your scope because it's just brighter.
And you mentioned all-night visibility.
That's the third big win. The planet rises right around sunset. It climbs highest in the sky around midnight, perfect position, less atmosphere to look through, and then it sets around sunrise.
So you've got, like, the whole night, no rushing before it disappears below the horizon.
Exactly. Hours and hours of prime viewing time.
Makes sense. Now, which planets actually do this? Can we see all of them at opposition?
Good question. No, not all of them. Remember, Earth has to be between the sun and the planet. So it only works for planets that are further away from the sun than Earth is.
Okay, so that's Mars, Jupiter, Saturn, Uranus, Neptune.
You got it. Those are the ones. Mars, Jupiter, Saturn, Uranus, and Neptune.
Which means Mercury and Venus, the inner planets, they never reach opposition.
Correct. Because they orbit inside Earth's path, we can never get between them and the sun. They always appear relatively close to the sun in our sky, mostly visible just after sunset or before sunrise.
Right. Those twilight appearances. Okay, and how often do these oppositions happen?
For most of those outer planets, Jupiter, Saturn, Uranus, Neptune, it happens roughly once a year. Earth is faster, so we catch up and lap them about annually.
But not Mars.
Mars is the exception. Its orbit isn't that much bigger than Earth's, and it's not moving that much slower. So we only manage to lap Mars about every 27 months or so.
So every 2 years, maybe a bit more.
Yeah.
Makes those Mars oppositions feel a bit more special then.
They definitely are. And just quickly, the opposite of opposition is called conjunction.
That's when the planet is behind the sun.
Basically, yeah. It's very close to the sun in our sky, usually lost in the glare, really hard, often impossible to see.
Okay, opposition good, conjunction bad for viewing. Got it.
Pretty much.
All right, now we know the what and why. Let's get to the when and where for 2025. What's the big headliner? Probably Jupiter, right?
Absolutely. Jupiter is often the easiest and frankly one of the most spectacular targets. So everyone grab your calendars. Jupiter hits opposition on October 15th, 2025.
October 15th. And where should we be looking?
It'll be blazing away in the constellation Taurus, the bull. You honestly won't miss it. It'll look like a super bright sort of cream-colored star that doesn't twinkle.
That non-twinkling is key, isn't it? Stars twinkle because of our atmosphere, but planets are close enough that their light comes through as a steadier beam.
Exactly right. And if you want help pinpointing it, or especially if you want to track its moons, apps like Stellarium or Skyview are fantastic tools. Just point your phone up.
Okay, so we found it. Now, the exciting part. What can we actually see? Let's start simple. Naked eye.
Naked eye, like we said, it's unmistakable. A very bright, steady, cream-colored point of light. Brighter than pretty much any actual star nearby.
Okay, easy enough. What if someone has, say, just a regular pair of binoculars, like 10 by 50s? Pretty common.
Now things get interesting. With binoculars, Jupiter stops being just a point. You'll see it resolve into a tiny, definite disk. That itself is a bit of a wow moment.
A tiny circle instead of a dot. Cool.
But the real kicker with binoculars, the Galilean moons, Io, Europa, Ganymede, Callisto, you'll see them as little pinpricks of light, usually in a line, flanking the planet.
And they move?
They move, look one night, then look the next, their positions will have changed. It's amazing to witness that orbital dance directly.
That's incredible. Okay, stepping it up. A small telescope? Maybe a 4-inch or 6-inch reflector, something manageable for beginners.
Now you're talking. With a small scope, details on Jupiter itself pop out. You should clearly see two main dark stripes across the disk.
The cloud bands.
Yep, the north and south equatorial belts. These dark bands are prominent features.
The big one. The great red spot. Is that visible in a small scope?
It can be, but let's manage expectations here. It's definitely more challenging.
Second.
First, it won't look like a bright red spot like in NASA photos. Think more. Pale oval, faint, maybe slightly salmon-colored if you're lucky and the conditions are great.
Right, not blazing red.
No. And you need two things. Really steady air, what astronomers call good seeing, because our atmosphere can blur details. And you need to know when the spot is actually facing Earth. It rotates around with the planet.
So it's not always visible.
Exactly. It only takes about 10 hours for Jupiter to rotate, so the spot is only visible for a few hours each night it transits. There are online calculators, like from Sky and Telescope magazine, that predict the Great Red Spot transit times. You got to check those.
Good tip. So steady air and good timing for the GRS. It really highlights how dynamic these planets are, doesn't it? Even observing from Earth.
Absolutely. It's not a static picture. It's a live view of a constantly changing world.
Okay, those are fantastic targets. To make sure people get the best possible views, what are some pro tips? Practical advice?
Definitely. First one is crucial, especially in cooler weather. If you're bringing your telescope outside from a warm house,
let it cool down.
Yes, let it acclimate outside for at least 30 minutes, maybe longer if it's a bigger scope. Otherwise, the warm air inside the tube creates currents that make the view wavy and distorted, like looking over hot pavement.
Good point. Temperature matters.
What else? Filters. If you have a telescope with interchangeable eyepieces, simple colored filters can make a surprising difference.
Like what kind of filters?
For Jupiter, a light blue filter, often labeled #88, or maybe a light green one, like a #58, can really boost the contrast of those cloud bands, makes them stand out more. It can sometimes help with spotting the Great Red Spot, too.
Okay, filters can enhance contrast. Worth trying.
And the last one is maybe the most important. Patience. Don't just take a quick peek.
Stare at it.
Yeah, really look at the planet. Keep watching. Our atmosphere is constantly shimmering, but there will be brief moments, fractions of a second sometimes, where the air becomes perfectly still. In those moments, details just snap into sharp focus. You have to be patient and wait for them. That's often when you'll glimpse the most detail.
That's great advice. Wait for those moments of clarity. Okay, Jupiter sounds amazing for October 15th, but 2025 has more, right? What about Saturn?
Saturn, always a favorite. Its opposition is a bit earlier, on September 21st, 2025. The exact time is Euro 5.0 GMT, which is 1:10 a.m. Eastern Daylight Time.
September 21st. And where will Saturn be?
Look for it in the constellation Pisces. It'll be shining brightly at magnitude 0.6. So definitely visible to the naked eye, looking like a bright yellowish point of light that doesn't twinkle, visible all night long.
Brighter than most stars. Got it.
And its distance. It'll be closest at about 8.55 astronomical units. That's what, around 795 million miles away, so quite a bit further than Jupiter. Its disk will appear about 19.4 arcseconds across.
Still tiny. Okay, so we need a telescope for the rings, obviously.
Yeah.
What's the deal with the rings in 2025?
Right. Here's the interesting thing about Saturn this year. A small telescope will show the rings, but they're going to be tilted at only about 2 degrees from our point of view.
2 degrees, so like almost edge on.
Exactly, nearly edge on. This happens periodically as Saturn orbits the sun, and its tilt relative to us changes over its 29-year orbit.
So does that make them harder to see? Or just different?
It definitely makes them look like a thin line rather than the wide open rings we often picture. So less wow factor in that sense, maybe. But it's a fascinating view in its own right. It really emphasizes how incredibly thin the rings actually are. Sometimes seeing them edge on can make it easier to spot some of Saturn's moons that might otherwise be lost in the glare of the wider rings. It's a unique perspective.
A different kind of beauty, maybe.
Yeah.
Okay, Saturn on September 21st, nearly edge on rings. What about the really distant ones? Uranus and Neptune.
The ice giants, yes, they both reach opposition too. These are definitely more challenging targets. You'll need binoculars or a telescope for sure.
Let's start with Neptune. When's its turn?
Neptune is just 2 days after Saturn, actually. September 23rd, 2025 at 12:45 GMT or 8:45 a.m. Eastern. It'll also be in Pisces, not far from Saturn.
In brightness.
Magnitude 7.8. So invisible to the naked eye, you'll need good binoculars, probably mounted, or a telescope to pick it out as a tiny bluish dot.
Can you see any features? Or moons?
Features are tough on Neptune, even with large amateur scopes. But with a medium-sized telescope, say 6 or 8 inches, on a good night, you might be able to glimpse its largest moon, Triton, which is surprisingly bright for being so far away.
Wow. And how far is Neptune?
At opposition, it'll be closest at about 28.9 AU. That's nearly 2.7 billion miles. Its disk is minuscule, just 2.4 arcseconds across. A real challenge.
Okay, Neptune, September 23rd. What about Uranus?
Uranus follows later in the year. Its opposition is November 21st, 2025 at 12.17 GMT, 8:11 Cine AM Eastern. It'll be back in Taurus, not too far from where Jupiter was earlier.
And its brightness. Magnitude 5.6.
Right. Now, 5.6 is technically just within the limit of naked eye visibility under perfect dark sky conditions.
But realistically?
Realistically, you'll want good binoculars or a telescope. It's much easier to confirm you found it. Through optics, it appears as a distinct, small, greenish-blue disk, noticeably different from a star.
Any moons visible for Uranus?
Yes. With a medium-sized telescope, you actually have a decent shot at spotting up to 4 of its brightest moons: Titania, Oberon, Umbriel, and Ariel. They'll be tiny dots very close to the planet.
Cool. And Uranus's distance?
Closest approach is about 18.5 AU, so considerably closer than Neptune. Its disk is a bit larger too, 3.7 arcseconds. Still small, but noticeably bigger than Neptune's.
Okay, so we have the gas giants, the ice giants.
Yeah.
But you mentioned even asteroids.
Absolutely. Opposition isn't just for planets. It's the best time to hunt for asteroids and dwarf planets too. In fact, it's how astronomers used to discover many asteroids by looking for faint points of light that moved against the background stars near their opposition point.
So this is more for the dedicated observer, maybe?
Generally, yes. Most asteroids are quite faint. But 2025 has a really special treat.
Oh, what's that?
The Dwarf planet Ceres. Remember Ceres? Largest object in the asteroid belt, smallest dwarf planet in our solar system.
Yeah, I remember reading about the Dawn mission visiting it.
Well, Ceres reaches opposition on October 2nd, 2025, in the constellation Cetus. And get this. It will be magnitude 7.6.
7.6. That's almost as bright as Neptune, which means
you should be able to spot Ceres with a good pair of 8x40 or, even better, 10x50 binoculars.
no way you could see a dwarf planet with binoculars.
Yes, it's a fantastic opportunity. It'll look like a faint star, of course, but knowing you're seeing Ceres, the closest dwarf planet with just binoculars is, well, it's pretty cool.
That is cool. October 2nd for Ceres. Any other relatively bright asteroids for binocular users?
Yeah, a couple more for those with maybe 10x50s or larger binoculars or small telescopes. There's 12 Victoria. It'll be magnitude 9.9 in Aries around November 5th. And 16 Psyche, the target of an upcoming NASA mission, will be magnitude 9.7 in Taurus around December 7th.
Victoria and Psyche. Still faint, but potentially doable.
Right. They'll require dark skies and careful searching using star charts or apps, but the thrill of spotting an actual asteroid, a chunk of rock orbiting between Mars and Jupiter. It's a unique feeling, a real connection to the solar system structure.
Definitely adds another layer to stargazing. Okay, this has been fantastic. Let's do a quick flyby recap. Opposition. Sun, Earth, planet lined up. Earth in the middle means closest, brightest, and all-night viewing. The best time to look. Key dates for 2025. Jupiter, the king, October 15th. Saturn, with those nearly edge-on rings, September 21st.
Neptune, the distant blue dot, September 23rd. Uranus, the greenish ice giant, November 21st.
And that really cool bonus, dwarf planet Ceres, visible in binoculars on October 2nd.
Yep. Plus a couple other asteroids for the dedicated. 2025 is looking really good for planetary observers.
Absolutely. So we really encourage you listening to, plan ahead. Mark these dates. Use the tips we talked about, letting your scope cool down, maybe trying a filter.
And definitely consider using a stargazing app like Sky Tonight or Stellarium Mobile. They make finding these things so much easier. Point it at the sky, and it shows you exactly where to look.
It really transforms things. Whether you're tracking Jupiter's dancing moons, appreciating the sheer thinness of Saturn's rings this year, or hunting down that faint glow of Ceres, each one of these oppositions is kind of an invitation, isn't it? To just step outside, look up, and reconnect with the huge dynamic solar system we're part of. What new perspective will you find under the stars this autumn? When you realize those bright dots aren't just dots, they're whole other worlds.
It really is a powerful reminder. We live in this world saturated with information, screens everywhere, but sometimes the most profound aha moments, the real connections, they just come from looking up, from actually seeing for yourself what's out there, experiencing that cosmic clockwork firsthand.